Okay, so we've played for a little longer, and where have we arrived?
You've arrived at
Where the computer will always win now.
Our computer has evolved, our machine that we made has evolved to always win.
Alright,
So go ahead, make a move.
So I will move like that.
Alright, so what position does that put us in? What box are we in?
2.
2.
So,
Okay.
computer only has one option, computer has to take.
Computer only has one option in box 2. Show box 2 on our snap cube chart.
So,
It's here. So you can see there's only one cube in there. And can you remove that pawn from the board? Thanks.
So then I will take with this.
So that puts us at position 12. There's also only one box. Computer has to take your pawn.
I don't think that's right.
Did we remove the wrong one?
No.
No.
The white, the yellow is the first move that the computer has. This should be a mirror position.
The computer.
In box 12.
The computer pushes.
There you go. The computer pushes show box 12 on our board there. Only one cube, and that yellow cube is the first move in the book, which is pushing.
Alright, so that means I only have one option. I have to do this.
Okay, and where does that leave us?
So that leaves us position 17.
Okay, and where is that on our board?
So it's right here. Or right there.
Okay,
So that.
and how many cubes do we have there?
Only one.
All right.
So, computer pushes
Has
for
to
the
win.
Okay,
So we have evolved.
let's play a couple more games to show that all along the way the computer's moves win.
Right. And we already showed that this.
Right, we figured that out in the last video. So push and then take.
So then I will push with this side now.
Okay,
That,
remove that white pawn from the board, please. All right, what position are we in now?
that position says that is at this position 7.
Okay, now we're on position 7 on the board. We still have 3 choices.
That means so.
But let's explore those 3 choices. Show those 3 choices on the board now.
So one choice would be to take, which wins.
All right.
One choice would be to move, which also wins. The other choice would be to take my pawn.
Okay.
In this position, I have to move
Or take.
or take.
So
Either way, if I move, the only 2 options are to move to here, which
Okay.
wins.
if
If I take
you
here,
either take
takes or moves,
for the
either move would win.
Okay, so there we go. I'm not sure that we've shown every single possibility, but I think we get the idea. All right, so tell me some things that you found interesting about this project.
So it's pretty neat. Even if this was just a simple game, probably computers can do this pretty quickly with more advanced games.
Okay.
And it's also cool that we made a computer out of snap cubes that can beat humans at this game.
Yeah, what was the name of this game?
Hexapon, I think.
Hexapon. So we made a computer out of snap cubes that could learn to win this game. So in the prior example in the book was doing the same thing with tic-tac-toe. Do you think you can program a computer to win tic-tac-toe every time?
Yes.
And I actually see how they do with chess. I think they see how they do like difficulty levels, so you can add more losing positions.
Very
to
good.
this.
Right, you could adjust the difficulty. But I want you to go back. I want you to think about tic-tac-toe. Can you win tic-tac-toe every time?
I can't win every time. I can
You-
make
you
sure
can-
that I don't lose it. I
You can
cannot. I can make it so that I will not lose.
Okay.
You can eliminate losing, but there's also the option of draw. But
Right. So
But
you think
here
a
it's
computer could?
impossible to draw.
You think the computer could win every time?
no.
No, I think the computer could not lose every time.
Okay. So yeah, we've got to be careful. It doesn't mean you every game you can win, but the computer can play optimally. And in tic-tac-toe, if you play optimally, you at least draw.
Yeah. Here, if you play optimally, you will always win.
Yeah, interesting. Well, so let's say what do you need to do to win this game if you play
You
optimally?
need to go first.
No, you don't need to go first.
You need to go second.
You need to go second. So-
in tic-tac-toe, you need to go first.
For optimal play in hexapon, the second player wins.
Yeah.
For optimal play in tic-tac-toe, it's a draw.
Yeah.
Optimal kitty cat is a meow. Okay. Anything else about this?
Not
No.
really.
All right. So you had a good idea about how they make difficulty levels in
Yeah.
chess.
Yeah.
All right. All right. How do you think you could do this on a computer to make it go faster?
You can run all the cases. You can probably program a computer to run each case. I mean, like what we did in like 10 seconds, the computer would do instantaneously.
Right.
So the computer could probably figure this game out in like 10 seconds, but just quickly just run all the possible ways this game could play out.
Yeah. Anyway, really cool. All right. This was fun. Good job, guys.